A summary on what we've learned so far with regards to the lambda expression. We know that we can have a parameter list and we can specify parameters for the lambda to accept. We also know that we can explicitly specify the return type for the lambda, and that the lambda has a body as with a function that can simply do something or print something out, but it can also return something. Now in this lecture I want to talk about the capture clause. A lambda cannot access variables from the outside scope directly. You actually have to specify the ones that you want to access either by value or by reference explicitly within the capture clause or list. Now of course you can pass certain variables in as parameters if you want, but the capture clause also allows us to specify which variables from the external scope we want to have access within the lambda function body. A lambda can capture or access variables from the surrounding scope. The capture clause specifies the list of variables to be captured and how they can be captured. It's kind of similar to the parameter list in that we can capture by value and we can also capture by reference. If you capture some variable from the surrounding scope by value, then you cannot make changes to that. You can also capture by reference, and in that case you can actually make changes to the captured variable. The capture clause is between the brackets before the parameter list. If you leave the capture clause empty, then the lambda captures no variables. If you specify some variable x, variable y, or whatever you specify, then we capture some variable by value. Notice that we do not specify the type. You do not do int x and so on. It is not a parameter. We can also capture some variable by using the ampersand, so we can do the ampersand and followed by some variable name, which again is from the surrounding scope. Then we can capture that by reference, and if we make changes to that in the body of the lambda, then that will be reflected in the surrounding scope as well, similar to passing by reference. Now we can also do capture all from the surrounding scope by reference. We can do that by specifying the ampersand by itself. Similarly, we can use the assignment operator to capture all from the surrounding scope by value. And of course we can mix this. We can mix capture by value and capture by reference. You can, for example, mix capture all from surrounding scope by value. Then you can also capture a specific variable by reference if you want to do that. So you can mix these. The capture clause is basically a list, a comma-separated list of variables to be captured. Again, reference captures can be modified in the outside scope. Modifications made to variables captured by value will not reflect in the outside scope. You can actually also not modify variables that are captured by value unless you use the mutable specifier, and I'll demonstrate that a bit later. A simple example: in the main function I have two variables right here, int x initialized to 3 and int y initialized to 5. Then I have this lambda down here. With this increment handle, we capture x by reference and we don't have any parameters. I'm going to increment x in the lambda body, and then I'm going to print out x. Okay, and then down here I'm actually going to invoke the lambda. You can see I have the increment identifier and I do the function call operator, and then here I'm going to print x out again. So let's just see what we get if I build around that. Remember that x was initialized to 3, so it gets incremented. Within the body of the lambda we get 4 printed out, and following the invocation of the lambda within the main, we get 4 printed out again. Again, this is similar to passing by reference, but if I go and capture x by value, I cannot go and make modifications to that. So I'll comment that out. And now if I build around that, of course we are no longer making modifications to it, so we're printing it out. That being said, you can use the mutable specifier. So I have the capture clause, the parentheses for the parameters, followed by mutable, and then the body. Now we can make changes to what we capture by value, and then I can print that out, for example. But now you'll notice that what we print out here within the body is not going to be the same to what we print out following the lambda invocation. Build around that. Invoking the lambda, we get 4 within the body of the lambda. Following the lambda invocation, we get 3. So the changes do not reflect within the outer scope because we are capturing by value. That is where mutable comes in handy. If we capture by value, then we can go and modify what we capture in the body of the lambda. Now let's say we want to do y here. You will notice that we actually get an error here. Local variable cannot be referenced in a lambda body unless it is in the capture list. For example, let's say we wanted to do this. Print out x and y maybe with a tab between those. Again, we will get an error because we do not have access to y within the body of this lambda. So build around that, and we will get an error. Y cannot be implicitly captured, and it talks here about no default capture mode. Now the default capture mode is, let's say we want to capture everything by value. Then we do the equal sign here within the capture list, okay, between the brackets. Then we capture everything by value. That is a default capture mode. So if I build a run now, we get 4 and 6 within the Lambda body. Following the Lambda invocation, we get 3 and 5 again. So those changes do not reflect within the outside scope. But of course, we can also capture all by reference by using the ampersand. And now those changes should reflect. Okay, you can see those do reflect. And the modifications are applied to the variables within the outer scope. You can mix those, so I can do the assignment operator or the equal symbol. So I'm going to capture everything by value, but I'm going to specify that I want to capture y by reference. So think about the output here for a second as an exercise. Go and pause the video and think about what the output is going to be. Alright, I'll just continue here and I'll build around this. Within the body, it's going to increment both and we're going to get those printouts. But following the Lambda invocation, we're going to get 3 for x again, because that is captured by value, not by reference. Y, however, is captured by reference, so that will reflect within the outside scope. That is, the changes or modifications within the Lambda body will reflect within the outer scope, which in this case is main. So again, why we use the capture list or capture clause is, again, let's say I do not go and capture all, then we are no longer capturing x, which is within the outer scope, and so we'll get an error here. We have to actually specify explicitly that we want to capture those outer variables and how we want to capture those. And I can also print out the addresses of those variables just to experiment with this. Remember, we're capturing all by value at the moment, so we're capturing x by value and we're capturing y by reference. If I go and build this, build a run, notice that y, which we capture by reference, has the same address, but x does not. We have a different address, so those are different variables. And I'll just capture all by value here. Build a run that, build a run. You can see the address for x and the address for y will change over time. The addresses for the variables x and y are different within the body of the Lambda and outside of the body, as we can see here for x and y. Also, the modifications are not reflected within the outside scope. As I've demonstrated, we can mix the capturing, so we can capture by reference or we can capture by value. Now, there are some issues that we can run into with that, and I'll demonstrate that to you in this next subsection. Firstly, as I mentioned, we have the default capture modes. We can capture all by reference or we can capture all by value. Capture all by reference again using the ampersand. Capture all by value using the equal symbol. Now, with those default capture modes, we have to specify the default capture mode followed by the opposite type of capture for specific variables. Otherwise, you'll get an error. So, for example, if you specify some variable x followed by some default capture mode, let's say we capture all by value in this example, then we'll get an error because the default capture mode should be first. And next, we cannot prefix variables with the capture by value. That is the equal symbol followed by some variable name. It is unnecessary, we only specify the variable identifier by itself. So unlike capture by reference, we do not have to specify capture by value by using a special symbol for that. Of course, if you want to capture by reference, then you have to use the ampersand followed by the variable name. Moving on, if a default capture mode has been specified, then an identifier cannot be specified to be captured in the same way. For example, if we capture all by value, and then we provide some other identifier as is, so we do not do capture by reference, using the ampersand followed by the variable name, then we will get an error. In this example, capture all by value again is the equal symbol, comma, and then y, so we are going to capture y by value. But we're already capturing all by value, so it's unnecessary for us to specify y here, so we'll get an error. Finally, an identifier cannot appear more than once in a capture clause. If you do some variable x or y twice in the same capture clause, right in the capture list, then you'll get an error. A couple of examples just to show you what I mean. Currently, I'm capturing all by reference. In the capture list, let's say we specify x to be captured by value, comma, and then the ampersand, then we'll get an error. So build that. We will get this error. Capture default can only appear at the beginning of a Lambda capture list. Same thing if you capture all by value. Ctrl B to build that. We will get the same sort of error. Next, let's say we want to capture x by value and y by reference, then we can do ampersand y to capture y by reference. But of course, to capture by value, we can only specify the variable that we want to capture, in this case x. We do not have to specify the equal symbol followed by the variable name. And if you try and do that, you'll actually get an error. To capture x by value, we can specify the variable identifier x. So we can remove the equal symbol, we do not have to specify the equal symbol, and we can build around that will now work fine. Next, let's say I want to capture all by reference, so I specify here the default capture mode is capture all by reference, and then I also specify capture Y by reference. Maybe the capture list is a bit long, so I missed the fact that I'm capturing Y by reference here as well as capturing everything by reference. So if I try and build around that, we'll actually get an error. Capture Y by reference cannot be explicitly captured when the default capture mode is by reference. To fix that, you will remove the capture Y by reference, or we will capture Y by value. Finally, another issue that you may run into is duplicate entries within the same list. Let's say we specify that we want to capture Y by value twice. This is something that you want to look out for, especially when your capture list is a bit long. Then you want to look out for duplicate entries, otherwise you'll get an error. To wrap up a syntax for the Lambda expression, first we have the capture clause, where we can capture variables from the outside scope, where we have to specify which variables we want to capture or access from the outside scope. Those are not implicitly accessible, as you can do with a compound statement, for example, or a for loop. Then we have a parameter list. We can pass arguments to the Lambda that we can use within the body. Then we can use the mutable specifier if we want to make changes to captured variables that we captured by value. We can also explicitly specify the return type, so the Lambda can return by an explicitly specified type. And then of course we have the Lambda body as well. And with this, we are going to wrap up this lecture. I'll see you next time.